Okay, we're going to cover two more things this semester, two more broad topics. And those topics are, we're going to touch on database integration, and we're going to talk about Ajax. Now, we've already seen Ajax sort of previewed on one of the assignments. Think about it. Well, I haven't told you what Ajax is, but we'll talk about what Ajax is, and we'll look back on one of the assignments that we had where we've already used Ajax. But as far as database integration goes, I want to revise the diagram that I always draw here a little bit to give a little bit more accurate picture of what's going on here. In the diagram I always draw, I have a client, which is someone surfing the web that is connected to the internet and makes requests that get routed to a web server, and the web server responds to those requests. So we talk about a web server as being software that, quote, listens for requests and then responds. And how does it respond? It responds with an HTML page that contains HTML, CSS, JavaScript, and some other files here. And we talked about simple cases of there being static pages, which means unchanging. That would be basic HTML pages like we did in CISS232, whereas the content is defined in HTML. And if you were to view a page today that you did whatever semester you took CISS232, you'd notice that it looked identical. And we talked about how most of the pages on the internet are not static pages, that most of them are dynamic pages. And dynamic pages are not completed HTML pages, but are scripts. Scripts is, think of script as being a program, a little program. Although some of these scripts are anything but little. And they are written in different languages, and the language we've been exploring is PHP. So a PHP file is not a completed web page. A PHP file has to be processed by the web server in order to create an HTML file that gets sent back to the client. Now, the final piece that we're going to consider for this on the server side is actually database integration. That is taking data from a database and using it to form a web page. Now you think about it, database integration is all over on our most popular websites. You know, if you consider Canvas. All right. There's a database somewhere that says that for CISS232, we have these modules defined. And this module contains this piece of content. This module contains this piece of content, and so on down the line. I can go add anything I want to simply by clicking a little arrow or a little plus sign. I can add something. I could add an assignment. We won't do that because we're near the end of the semester. I could add a page though, for example. And page name, call it test. What happens when I click add item? When I click add item, it is actually going and updating a database with the information that in the week 12 module, there is now a new page. When I go in and edit that, I can type in, this is a test page. And when I click save, it updates it. I can go back then and publish it. That will actually make it active. All those things that I did right there were database operations. When I clicked the plus sign and added something, that was doing an insert into a database table somewhere, or possibly tables. Might be a better way to put it, because I don't know the internal structure of the Canvas database, but I can make some guesses, and I would say that that probably updates a couple of tables. When I go and edit that page and change the content, and I click save, that is updating a table. When I click publish, that is updating a table. All right. All those are database operations. Now, I'm going to leave this out here just for to demonstrate that if any of you were to go into Canvas right now, you would see under week 12 the page test. All right. And again, how does that happen? Is there an actual page that's created? No. The data is stored in a database. And that data is retrieved when you go and log on and look at CISS232. Now, in past examples, I've drawn a line between these two. And that's not entirely correct. Because really, with databases, there's actually a go-between. And that is a DBMS, or Database Management System. The DBMS, or Database Management System, is a database server. It's a server just like the web server is a server. And what does it mean when we say that a computer or a computer system is a server? We mean that it accepts requests and it responds to them. Okay? So, in the case of Canvas, this script, which displays a course, before it displays the course, it's going to go out and it's going to request certain data from the DBMS. Namely, what are the different modules and pieces of content for this particular course. The database will retrieve that and send it to the web server, and the web server will take that data back from the database along with the script that is created in possibly PHP, but probably some other programming language, and it will weave them together to create a web page that gets sent back to the client. What happens when you log on? The web server is going to request a database, hey, are these login credentials correct? What happens when I go and add a page? The database, the web server is going to ask the database management system, the database server, to add a row in a particular table or update a row or so on. So all that happens, all that data is stored in the database. These websites like this are dynamic and they're often called data-driven. Because if you don't update the database, you don't have anything. If I go in the first day of classes and I haven't gone in, if you were to come in the first day of classes and I haven't gone in and updated the database for that particular class, you would see nothing under content because all the content comes from the data that is stored in the database. So, database system, database server takes requests, and those requests are typically basic SQL statements. All right, SQL is the language of databases. SQL stands for Standard Query Language. and it is the chief way that we interact with databases. Now, just as a footnote, some of you that are enrolled in CISS233, we access data a different way. We use LINQ, L-I-N-Q, to access data from the database with our entities and our database contexts and all that. But by and large, the other main way to do that is via SQL statements. Now, I don't know if all of you have had CISS2 143 yet, so we're not going to delve deeply into SQL statements, but we are going to touch on them. All right, touch on some of the basic ones. So, what are we going to use in this course as our database server, as our DBMS? We are going to use a database called MySQL. MySQL is can be run on any platform. So whether it's Mac or PC, it doesn't matter. It can run on those or Linux. All right. MySQL is a true database server, unlike Access, which is not really a database server. And so you will need to do our next assignment, you'll need to download MySQL. Here's the good news. If you have installed XAMPP, you've already installed MySQL. All right. And when you start XAMPP, if you notice, there's a place for you to start the web server. There's a place for you to start the MySQL server as well. All right. So you should already have that taken care of. If for some reason you do not have MySQL installed, you can easily find resources to install it. It's not that hard. My only suggestion would be when you install it, choose the legacy style for security and authentication. We'll touch on that in a minute. It's a simpler form of logging on to the database as opposed to multiple factor logons to the database. So we download MySQL. Now, how do we see the stuff that's in the MySQL database? How do we create databases? How do we view the databases? How do we view the data in the databases? There's an application available that does that for you, which is essential, and you'll need to download that as well. And that is called MySQL Workbench. So we're going to go into that now. Oh, on MySQL Workbench. When you come up to this, you'll notice MySQL connections. Now, this is set up to have the database running on the same machine that we're running on here. All right. What does that mean? That means you can possibly connect to other databases running on other web servers on your database. This will connect to any of them, provided you give the right information. In this case, the instance of MySQL, the instance of the server is called MySQL 80, and it is run on localhost using port 3306, which is, I imagine, the default port for MySQL. And the user ID that's connecting to it is root. So to connect to a MySQL database, you need to know the machine that the MySQL database is running on. You need to know the name of the instance, and you need to know the credentials. So I'm going to click on this, and it's probably installed with no password. And I log in, and here I am. All right, this shows me the SQL server status. If any clients are connected, users and privileges, and so on down the line. We also see schemas, which are basically the databases that are available, because you can have multiple databases within a single server. This is the system database that contains data about the configuration of MySQL. We have over here queries. And queries are where you can run SQL statements to set up the database. All right. So we can run statements here to create tables. We can also create tables through the GUI. So I could, over here, I could add a new schema this way by clicking that to create a new schema on the connected server. Or I could run a SQL Server script to do that. Scripts are often used as opposed to going through the GUI because oftentimes if you have a database on, say, for your development machine, oftentimes you'll need a script to go and apply the same changes you've made to the database to your production machine. So if you're creating a database on your development machine and you're developing a new web application that uses a database, at some point you're going to need to put that on your production database server, on the actual live database server. So by having a script, I can take that and I can run that and bring the database there up to date. All right, so for this lab, we have a script that you're going to run on your database. And we'll spend a minute looking at the script. We're not going to study it in detail. They typically end in .SQL. We can open it up with Visual Studio Code. And this is from a tutorial that I've used. Like many programming languages, it allows you to put comments in the code. This actually puts in and creates a database called classic models. That's what line 26 does. Line 28 says for the rest of the instructions in this script, we are going to use that classic model database. One thing that's a little confusing, database and schema mean pretty much the same thing. So if the table exists, we're going to drop customers. And we're going to create the table with these attributes: customer number, customer name, and so on down the line. We create it with certain constraints. Primary key uniquely identifies rows in a database. So every customer must have its own customer number, and it has to be unique. In other words, two customers cannot share a customer number. And then some other things such as foreign keys. I won't go into this in too much detail, as I mentioned before. If you're familiar with relational databases, if you've had CISS232, I would hope some of this will be familiar to you. If not, you will learn about it at some point. Now we're adding data to the database. So we're inserting into the customer table this data. A whole bunch of rows of data. Then we create an employees table. And we add in some employees. We create an offices table. And we add in some offices. We create some order details. So we're creating a bunch of tables and adding to it. I think that's pretty much all. We create a bunch of tables and we add it to it. And we'll look at the tables in a second here because we're going to actually execute this script. Now, scripts typically are that they will run as a unit. So if I choose to run this entire script, it will run everything and the whole thing will either succeed or fail. There is a mode where I can run one instruction at a time, and that will be a little bit different. All right, so let's go in here, and I'm going to open up that script by going to open up SQL script that has in a new query tab. Any database operation is called a query. Don't think just because it says query, you're only like looking up data. You know, to insert data into a database, that's a query. A query in a nutshell is a request that you're sending to the database. And in this case, this application, MySQL Workbench, is making requests to the MySQL database to create a new database, to add tables, to add data, and so on. So pick this up. And there's the script that we were just looking at. I want to execute the whole thing, so I'm going to select all, as opposed to the other mode that executes a statement under the keyboard cursor. So I could do one at a time if I wanted to. So I'm going to execute this script. So I click on the lightning bolt. It does its thing. It tells me what it did. Some of these are creating tables. Some of these are adding new records to the table, and so on. Now, when we're done here, we now have in our schemas a new database that contains these tables, the customer table, and we can see the data in the customer table. The offices table, we can see the data in the offices table, and so on. Now, I'm not going to go into the details here, but I would suggest we run another script in here. MySQL databases at some point, I believe in version 8 or around the point of version 8, changed the way that authentication was done from a single factor to a default multi-factor. Well, for simplicity's sake on our assignment, we're going to go back to the old way of doing things, which is just a single factor. So I have a script in Canvas that I would suggest that you run, and it's called instruction to change password. So just copy this, and this is going to set the new password for the root of the localhost server to using the old style password. That's what MySQL native password means. And the password itself is actually going to be password. Obviously, if this was something that was going to be used heavily or in production, you would want to change that. You would not want it to be simply password. But for our case, we can do that. So I'm going to go here. I'm going to create a new SQL tab. I'm going to insert those two statements. I'm going to run it. And now we have implemented those changes so that the root password is now password. Remember what you change your password to. One of the reasons I'm asking you to do this is that in some cases, you know, I'm hoping I'll be able to remind you of your password if you run into password difficulties. But now we're using the old authentication scheme, and the password for the root is password. Because remember, we need to know a couple of things that connect to this database. We need to know the name of the server, which is our machine, which is localhost. All right, localhost is a name given to our machine, always, the specific machine that we're on. And again, it could be another machine, right? In our case, the web server and the database server are the same machine, but there's no reason why they have to be. You could have the web server running on machine A and the database server running on machine B. All right. And in a larger project, you would likely have that. Remember, a server is a mechanism for getting requests and responding to requests. All right. So now we have this. I have a PHP code called offices that inquires from the database and pulls up a list of the offices with the city and phone number, I guess. I guess it displays the city and the phone number. So let's look at this. It's like any other PHP page. It's basically an HTML page that contains some PHP code. So we have our start of our HTML document, our head section with the title, our body that contains a PHP block. These lines of code are the lines of code that connect to the database. What is the machine of the web server? 127.0.0.1. I thought we said the machine was localhost. Those two things mean the same. Every computer has an IP address associated with it, and the IP address of your computer is 127.0.0.1. So when we go in and we try to pull up a PHP page and we've moved our files over to the PHP server, PHP server's home directory, and we type in localhost / and the name of the file, we could just as well type in 127.0.0.1, which means this machine also means localhost. I think that's called a loopback IP address. Our user ID, root, our password, we just changed it to password. And our database is classic models. That was the database schema that we created. Classic models, if we remember that script, one of the first things we did was we created a database called classic models. All right, now we're going to create some objects. These objects are the mechanism by which the web server can make requests to the database server. First thing we have here is we have creating a connection. It's going to try this statement, and if it fails, it's going to display the MySQL error. This is establishing a pipeline, a connection to the database server. And it's going to use these parameters. Now, we can imagine, based on our discussion of include files in the past weeks, some of these things, like these things, are really good candidates to put in an include file. Because every page that uses a database is going to need, more than likely, to connect to the same database server. I suppose it would be possible where you had multiple database servers, but in most cases you would have one database server. So this would be constant on all the pages and would always be creating a connection to that database. So this establishes the pipeline that connects the web server with the database server. Here we're making a request. That request is to run a query using this connection, and I screwed it up, using this connection that we've defined up here, and the query is select star from offices. All right. Select is a way to get data out of the database, get data out of a database table. And select star simply says, give me every row and column from the offices table. So what it's going to return is this. It's going to return a list of offices from the database. It's going to return all the information about them, all the rows. And it's going to return it as a data set. All right. It's going to return it as essentially a table of data, right? It's going to have multiple rows in it, and it's going to have multiple columns in it. Because we asked for all the columns and we asked for all the rows. So this creates essentially an array of results. Sort of a two-dimensional array. Now, echoes, this string is outputting the table header. This is going to loop through for every row that's in the result set. It's going to output, and it's going to give me the city for each row and the phone number for each row. So every time through the loop, this variable X gets filled in with an array that corresponds to a different row in the result set. And we ask from the array the city field, we ask from the array the phone field. So we're going to get the city and the phone number. Actually, let's go ahead and run this. Probably should do that instead of just talking about it. So let me make sure I save it. I'm going to copy this and I'm going to put it in my special web server root folder. All right, there we go. And I'm going to run localhost. And it's funny, I don't remember getting this error before, but I got it when I was testing this yesterday. This is saying that we are not going to see a directory listing, that we actually have to type in the exact file name we want. So I'm going to type in localhost offices.php. And that's going to look in the web server's root directory, which is CINetPub www. It's going to look for the file named offices.php. And there we go, a list of our data from the database. Now, of course, when you do something like this, my example is very bare bones because all I wanted to illustrate is the database access. When you do an assignment, you should finish this up and make it look like a good professional web page. Get to where I want to be. Now, to prove my point from before, 127.0.01 is the same as localhost. So if I type in 127.0.0.1, gives me the same answer. Now, why did I use 127? Why not just use localhost? Well, to teach you that it means the same thing. But also, I do remember a case of having problems using localhost that under certain circumstances, it wanted to see the 127.0.01 instead. I don't think it was in this case necessarily, but I've just gotten a habit of using the numerical thing. Now, if anything is wrong, let's say I give the wrong user ID. I don't get anything. Why don't I get anything? Well, if you remember, the PHP ini file is set to not allow displaying errors. So what I'm going to do is I'm going to create this. I'm going to find display errors. Turn the errors on. I'm going to save this on the desktop because of permissions. It's a good idea if you make any changes to your ini file to keep a backup of it. I'm not going to follow my own advice here. Then I'm going to go copy that over into its proper location. The permissions won't let me save it in that location, but I can move it over because it will give me this warning, and I can say, yeah, go ahead and move it. Now, when I run this, I'll get the error that says access denied for user roots, localhost, using password, yes, and we get a error here. So again, I would suggest you always turn on, and we've talked about this before, always turn on your error reporting so that you can see the error. Now, here's one thing that is, and those of you that are taking CISS243, we talk about link and we talk about the advantage. There's no processing to make sure that this is a valid SQL statement. So if I change this to point to a table that doesn't exist, it gives me this error. It doesn't know until you go to run it that that's not valid. Likewise, if I put something incorrect here, it gives me a warning that that doesn't exist, and it can only show the city name and not the phone. This catch exception allows us to, and it's a good idea to wrap any instructions that you have that access a database in a try catch block. It will try to do this. If there's an error, it will catch the exception and display a message. Now, this is a little bit redundant because we have these or die statements that display the error if there's a problem with that. So this in a nutshell is how to do database access with this. Again, were CISS232 a prerequisite, we would spend a lot more time with this. But it's easy to see how we can change this. How could we change this to be a search for Office instead of just a list of Office? Well, for those of you that know SQL, that would be adding a where clause here. Where city equals, and then would have some variable that would contain the string that we want to make it equal. How would we make it to add data to the database? Well, we would have an insert. The SQL statement would be an insert and not a select. To delete, it would be a delete and not a select. To change, it would be an update and not a select. Now let's see what your assignment is, because I forget. Oh, that's 9. Oh, that's 10. This is week 12. Actually, I have a couple weeks on this one. Just because so much of the work of this one is going to be getting everything installed and working correctly. The way that you can tell that you've gotten everything set up correctly is if you can run My Office as PHP and get the results that I did. Your lab is going to be, you're going to test that out, then you're going to create a PHP page that shows all the customers, and it's going to be sorted by customer name. And here's how you sort the SQL statement. So a big part of this assignment is just making sure you have everything set up correct. All right, making sure you have SQL Server, MySQL installed rather, and the Workbench installed, and that you've updated things and all that. That is an important part of software development. It's not all just writing code. It's making sure that you have the tools installed, configured correctly, so that you can do your job. All right, so that's part of the job too. So I think it's fair game to teach that and require that as part of the class here in client server scripting. Do we have any questions out there? Yes, go ahead. Is MySQL Workbench? No, I do not believe MySQL Workbench is included in XAMPP. MySQL is, but not MySQL Workbench, so you'll need to install it. And I have a discussion of how to install it in some videos here in the week 12 module. Links, how to use MySQL Workbench, how you can use the file to create the database, all that stuff that I covered. In addition to covering today, there's information on how to install that and all. Any other questions? All right, that's all I had today. We will either see you in lab or we will see you next week. Thank you.